Okay, so when we're starting with exponents, we need to look at things in, there's going to be exponential form, which is when we actually see the exponent. Then there's expanded form, which we don't really look at a lot, but this is kind of how you learn about exponents. So in this case, we've got 2 to the 4 is 2 times 2 times 2 times 2. And then evaluated form is actually figuring out what that is. So 2 times 2 is 4, times 2 is 8, times 2 again is 16. Okay, so exponential form, 2 to the 4. Expanded form, 2 times 2 times 2 times 2. Evaluated is just evaluating the number. So a lot of the questions that we're going to look at, it's going to say like write in expanded form and then evaluate. You really need to pay attention when you're doing these questions to answer the question that's being asked. So a question like this, where it says write in an expanded form first, this would be a 2-mark question. Okay, we're going to write it in expanded form, that's 1 mark. And then we're going to evaluate. So 3 times 3 times 3 times 3 is 81. But then we have to look at the signs. The first two, a negative and a negative, make a positive. Then a positive and a negative make a negative. And then, so putting these two together, sorry, I'll change colors here. Putting these two together would make a positive. 2 negatives make a positive. Then if I put that with this, a positive and a negative would make another negative. And then last, 2 negatives is going to make it positive again. Okay, on the next one, we've talked about this before. That negative goes in front, and then we have 3 times 3 times 3 times 3. So that becomes 81, but with a negative. Okay, so moving along here, we've got negative 3 times negative 3 is 9, times negative 3 again is negative 27. All right, now this last one, or second last one, sorry, is a little bit harder, but it's just harder because the numbers are different. It's not any harder in the actual question because we're doing all the same thing. If you know how to use your calculator properly, you can actually just put 3.5 to the 4 in your calculator. Sometimes it's a little hat, sometimes it's an XY button, but it's going to give you 150.0625 as our answer. Now, this one here is a little different because whenever we have a fraction, our exponent always applies to the top. So 2 times 2 times 2 times 2. And the bottom, 3 times 3 times 3 times 3. So 2 to the 4 is going to give us 16. And 3 to the 4 is going to give us 81. And we can't reduce that at all, so we would just leave that the way it is. Okay? Okay, so now what if we have two things that we're putting together? Well, the way I'm going to do this is I'm going to write it in expanded form first, just to kind of show you. So we've got 3 to the 2 times 3 to the 4. So this is going to be 3 to the 2, so 3 times 3, times 3 to the 4, which is 3 times 3 times 3 times 3. Well, really, if I put these brackets in, because that would be what this looks like, it's not actually changing anything. Okay, so I could take these brackets out, and it would still be the same question, because 3 times 3 times 3 times 3 times 3 is still going to give me the same question. So this is actually going to give me 3 to the 6. All right, the next one, if we look at it, we've got 2 times 2 times 2 times, so that's the first group, 2 times 2 times 2 times 2 times 2, that's the second group, times 2. Well, this is really, how many 2's do we have? Well, this is 2 to the 9 as a single power. We're writing these as one power. Okay, here we've got k times 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 k. That's really hard to write, but it ends up just being that we have 8 k values. So k to the 8. The general rule here, so I'm going to write it down at the bottom. So I'll just do that, throw a little arrow there. The general rule that we have is for the product rule. So this is the product rule for exponents. Okay, so we're dealing with exponents because there's other product rules in math. But for exponents, when we're dealing with the product and we have the same base, so let's say we have a base of a to the n, if we times that by a to the m, well, the answer is going to be a to the n plus m. If we look back at our example, the first example we had 2 and 4. Well, 2 plus 4 is 6. The second example we had 3, 5, and 1, because even though this isn't there, there's a 1 there. So 3 plus 5 is 8, plus 1 is 9. In the third example we had 3 plus 5, so it's n plus m. Okay? Now, if we look at quotients, now I'm going to write this a little different, because we know that when we're dealing with quotients or divisions, this is also the same as this. 3 to the 5 over 3 to the 3, or 2 to the 7 over 2 to the 1, or k to the 8 over k to the 5. That looks like a 6, so let's change that. 5. Okay, so the reason I'm going to do that is I'm going to actually write these in brackets. So we know that if I put 3, 2, 3, 4, 5 times on the top, and then 3 times on the bottom, well, when we talked about reducing fractions, we know that anything on the top, as long as it's multiplication, can reduce with anything on the bottom. So what I'm doing is just reducing all of those numbers. Those all become 1s, and 1 times anything is just itself. So what we're left with is 3 to the 2. Same thing if I did the 2s. Well, I'm going to have 1, 2, 3, 4, 5, 6, 7, all over 1. And that can cancel with just my first one. And I'm left with 2 to the 6. Here, we've got k, 2, 3, 4. Wow, this is annoying. 5, 6, 7, 8. All over. Now there's going to be 5 of them here. Now it doesn't actually matter which k we reduce it with. I always reduce it with the ones at the front. But it doesn't really matter which one you do, because you're going to get the same answer. We've got k to the 3. Okay, so what we're doing here for the general rule here is we're taking our same, the important thing is we've got the same number on the base. Okay, we've got a to the n divided by a to the m equals, now in this case it's n minus m. Okay, that's the same as if we write it like this though. So I don't want you to get confused. So we could have that. Now, one thing that we should note is sometimes this is going to give us a negative exponent. A lot of people get a little bit confused on how to deal with that. Well, when we're dealing with that, if we were to look at this first question we could do 2 times 2 times 2. This is if we were to write it out the old way. We get all of this. And I just want to show you what actually happens here. What we're left with is that cancels with that. Those cancel. Those cancel. So these, remember, all become 1. Okay, and that's something that some people forget. We're reducing these down. So what this is giving me is 1 over 2 squared. Now, if we look at what we have here, if I just do 3 minus 5, 2 to the 3 minus 5, well, that's going to give me 2 to the negative 2. Whenever I have a negative exponent, it just flips the side of the fraction that it's on. So this is 1 over 2 to the 2, because really, this is 2 to the negative 2 over 1. Okay, remember, we always have 1 on the bottom of a fraction. All right, now, well, there's another unique step. Well, what if we get 2 to the 0? Well, 2 to the 0 is 1. 3 to the 2.68 is 1. And 2,942 to the 0 is 1. All of these values, or sorry, the second one should be 3.268 to the 0 is 1. All of these values are 1 because of this rule. Okay, so if I look at this rule, we're going to have this is 2 times 2 times 2, all divided by 2 times 2 times 2. Well, those cancel, those cancel, those cancel, and they've all changed to 1s. So we're left with 1 to the 3 over 1 to the 3. Well, that's just 1. Or if we look at it this way, it's just 2 times 2 times 2 is 8 over 8, which is 1. Okay? Now, what we have to remember, though, is this is really equal to 2 to the 3 minus 3, which is equal to 2 to the 0. Well, 2 to the 0 is equal to 1. I just showed you 2 ways that it's equal to 1. Any value of 0 is going to give you 1. All right, so the textbook for this course is found in the Google Classroom. There's a link under the classwork section, so you can find it in there. There's a PDF, or you can download it. And we're going to be working on questions on page 114, numbers 3 to 6, 8, and 11.